Okay, good morning friends. Welcome to the session once again. Okay, we have one more minute, so we'll wait for some more learners to join in. After that, we will continue. Okay, come on, join. Today we are going to conduct the third session under our climatology section. Okay, third session under our climatology. We have already completed two sessions. In the first session, we have seen different types of composition of the atmosphere, different layering of the atmosphere, and in yesterday's session, that is the Ishita Goyal, good morning. How are you? How are you? Yes, good morning once again, Goyal. Yes. So in the second session, that is yesterday, we have seen the distribution of the insolation. Means the sun insolation, how it is coming and how it is distributing based on different latitude. Today we are going to discuss, yesterday we have studied the distribution of temperature also. We have seen four important factors in temperature distribution. Today we will continue with the different types of factors which are determining the temperature distribution. After this we are going to see the isotherm. Isotherm is line connecting the locations experiencing the same temperature. Okay, yes, I am also doing very well, thank you so much. How is your preparations going on, Ishita? Okay, now before we go into the session, I just have one information to make, that is in Unacademy platform we have started a UPSC Civil Service Examination comprehensive course on December 1st this month. You can chip in anytime now also for 2022 as well as for 2023. Okay, your prelims exam is there on 5th June, mains on 16th June, that is 2022. Similarly, your prelims is expected for 2023, mean May or June 2023. Okay, so accordingly you kindly make your roadmap. Nothing like practicing for your prelims via MCQ. Taking this into consideration, under the Unacademy platform, you have three different types of MCQ. One is the Unacademy Compact, which happens every Sunday at 11 AM. It is available both in English and Hindi. Okay, stuck in a sense the video or the preparation. I hope my audio and video is working fine. Stuck in a sense your preparation or the video. And the other type of test series is T20 Daily Current Affairs, 15 MCQ in 15 minutes, Monday to Friday 7:30 PM. Abhiyan is the static portion. Okay, that also 15 MCQ 15 minutes, Monday to Friday at 10 AM. For this you can use my enroll code, that is SUNEP10. Okay, I see. Don't worry. See, don't worry Ishita, you see like this. It is not only you that is experiencing such kind of a jerkiness in the preparation. Okay, everybody faces the same thing. But the one important point is you will have to compose yourself, regain energy, plan accordingly, and put an effort to maintain the consistency of your preparation. Okay, failure is a part of everybody's journey in the process of achievement of anything. Okay, so you will fall down sometimes, but the most important thing is you should know how to stand up again and march ahead with your dream of becoming the administrator. Okay, anyways, under this Unacademy platform we have 20 specific GS book, so you kindly try to catch hold of this book. This book has been written and curated specifically for UPSC. All the important points which is there in your GS syllabus is well written in this, is involved here, and also taking care into consideration the dynamic nature of the UPSC exam, and it has been reviewed by Unacademy top educator as well as the previous year UPSC toppers. Clear? It is available both in English as well as in Hindi. Let us begin our session today. Okay, Ishita, I hope that is. Shall we begin the session? or we'll wait for some more learners to join in. We will begin the session. Okay, time is running out. We don't have much time. Okay, the session is just for 40 minutes. Okay, shall we go ahead? Chalo, we'll go ahead with our discussion. Okay, you see here, yesterday we have seen some other important factors in the distribution of temperature. Distribution of temperature on the Earth's surface. Okay, one was the angle of the sun insolation, whether it is concentrated or diffuse. Depending on that, the intensity of the sun insolation we have seen. The second is duration we have seen. Now, third and fourth was regarding the ocean current and prevailing wind. The fifth important factor for the distribution of temperature on the Earth's surface is the nature of the ground slope. Nature of the ground slope is, say for example, you see here, this is sun insolation is coming. Now, if the mountain is oriented in this manner, this side will receive sunlight because it is in the sun facing direction. On the other side, it is in a shadow region. So, sun will not be easily available in this particular zone. Therefore, I will just give you an example. See, this is my Earth, this is equator, the sun insolation is here. Apparent shifting towards north and south is there, but it is always tied with the equatorial region. Now you see here, say for example this place, you just consider Himalayan mountain ranges. The orientation of Himalayan mountain ranges is from east to west or west to east, you can say. Therefore, in such a orientation of the mountain, which is east to west or west to east, then the southern side, here, kindly follow the pointer, the southern side of the mountain will receive sufficient rainfall, sufficient sun insolation. On the other side, the northern side will be the shadow zone. So in the same height, towards the sun facing, higher temperature as compared to the corresponding northern side in the same elevation. Okay, and suppose if I draw a snow line will also be like this. On the southern side, since the sun insolation is there, snow line is much upper. But in the northern side, since the sun insolation is less, the snow line you will attain at a very little height from the ground surface. That is the implications of this nature of the ground slope. Nature of the ground slope is how different mountain ranges are aligned. Say for example, in the Rocky Mountain, it will not be like that. Why? Because the Rocky Mountain, the Andes mountain ranges, they are oriented from north to south like this. But in the mountain ranges like Himalaya or the Alps mountain or the Himalayan mountain, which is oriented in the east to west or west to east direction, because by the virtue of sun being located near the equatorial region, the southern side of the mountain, like say for example Himalaya, will receive more sunlight as compared to the northern side. That is another factor. The sixth important factor for distribution of temperature on the Earth's surface is the nature of ground surface. You see here, let me just give you one example. Say for example, if a sun insolation is coming, if it is a white color, okay, white color, it reflects all the light. If it is a black color, it absorbs. Now, in between these two extremes, depending on different color, certain rays are observed, certain rays are reflected back. Similarly, on the Earth's surface, not all the surface of the Earth reflects the sun insolation in a similar manner. Reflection of sun insolation is based on the nature of ground surface. The nature of ground surface is determined by different color. Example, say for example, if it is a snow covered or ice covered region, then the reflection will be quite efficient. If it is a vegetation also depends. If it is a grassland, if it is a forest area, okay, or if it is an agricultural area, land practiced, okay, so the nature of the ground surface will determine how much sun insolation is reflected back. This is known as albedo. Albedo is nothing but you can say the reflectivity index of sun at the surface area, whatever the surface is. Okay, You see here, depending on this, the temperature distribution will be there. Why? Because if any surface is reflecting the sun incoming solar sun insolation efficiently, or if the albedo is very high, the warming of the ground surface or the atmosphere will be less. Keep this in mind. On the other hand, if any surface observes the sun insolation and not reflecting efficiently, then that particular area will be having higher temperature. And in here we are discussing the factors responsible for distribution of the Earth's temperature. You see here, this is a albedo table. You can see it is a percentage of reflectivity. Okay, albedo. You see here, fresh snow. Even under the snow, it can be divided into two. The fresh snow is very efficient in reflecting the sun insolation. Means having a very high albedo as compared to all snow. If it is all snow, then it is less as compared to the fresh snow which is happening. This you see here, cumulus stratus. This is a cloud type. Even under the cloud, cumulus and stratus cloud, they reflect much better as compared to stratus or alto stratus cloud. Clear? You come here, the dry sand. Okay, see, even under the sand, the reflectivity index or the albedo is different. The dry sand is higher as compared to a wet sand. Okay, you see here, savanna, the grassland, the crops, the water, the forest. So these are the different albedo, that is the reflectivity index. Depending on this reflectivity index, the sun insolation which is coming, it is reflected, and it depends on the ground surface. Clear? The seventh important factor is distance from the coast. Okay, how far the distance from the coast? Kindly pay attention. Let me tell you one point. You see here, if it is a land area, okay, this is a land, this is water, this is ocean. Say for example, this is ocean, this is land. We know there is a land breeze and sea breeze. Now, any location near the water body will have a moderate type of climatic conditions. In a sense, during the daytime, it is moderated by the ocean. During nighttime also, moderation effect happens. Therefore, a very rapid or a abrupt change in climatic conditions, or here I can say a temperature increase or decrease, will be not that much abrupt. But the moment you go deep inner and inner towards the land, the rise and fall in temperature, depending on the season, that is summer or winter, or daytime or nighttime, the rise and fall in temperature will be quite rapid. Means it will be abrupt change, or you can say the change will be very much. This effect is known as continentality. Continentality. Okay. Why it is so? It is so because of the nature of land and water as far as specific heat is concerned. What is specific heat? Specific heat is some amount of heat energy required to increase a unit volume of that particular surface by certain unit of temperature. Now, specific heat of water is much higher than land, which means it requires more energy, okay, to heat 1 unit of water to raise up to certain unit of temperature. But the land, the specific heat is much lower, which means it requires less heat to change the temperature of the land. Now, because of this, you see here, during daytime, okay, say for example, this is ocean, this is land. During daytime, the increase in the temperature in the land will be much faster as compared to water. During night time, the cooling down of the land will be much faster as compared to the water. Therefore, there is a rapid increase or decrease of the land temperature as compared to the water body. And the more you go towards interior, since you are moving away from the moderating effect of the ocean, then the increase and decrease of the temperature, depending on the season or depending whether it is daytime or nighttime, the variation will be much more. This effect is known as continentality. Clear? Now, you see here, that's why you see, say for example, what is isotherm? What is isotherm? Isotherm is nothing but line connecting points or locations experiencing the same temperature. Let me just give you one example. You see here, kindly follow, okay, very important. You see here, say for example, this is my continent, okay, this is a continental area, that is land area, this is a ocean, okay, water body. Say for example, it is a summertime in the northern hemisphere, okay, say for example, it is a summertime. In summer, what will happen? In summer, it will be very warm, means temperature will be more, but the temperature between water and land, in land the temperature will be much higher. Why? Because the specific heat of land is less, therefore it will heat up much faster. Therefore, in land the temperature will be much higher. In the ocean, temperature will be much lower. Another important point that we know is, in general, if we consider, the temperature decreases as we go from equatorial region towards the polar region. That is the general conclusion that we can make. Okay, temperature decreases as we go from equatorial region to the polar region. Now, if I try to draw an isotherm, the isotherm will be, how the isotherm will be? Say for example, temperature is higher here, okay, at this particular location, at this is a land area, so say for example, this is my temperature, isotherm. Over the ocean, I will have to come down below like this, towards lower latitude. Why? Because at the same latitude, the ocean water will be much cooler as compared to the land. Clear? So my isotherm will curve towards the equatorial region during the summer season. During winter, what will happen? It will be cold. Now, the continent or the land will cool down at a much faster rate. Therefore, at the same latitude, if I draw an isotherm, what will happen? Say for example, this is my land area. Okay, I draw one isotherm here like this. Now, at this particular latitude, the water will be much warmer. Much warmer. Why? Because the land is cooling at faster rate. Therefore, at this latitude, the water will be much warmer. In order to find this temperature, I will have to go above like this. So that is the nature of isotherm that you will find. Like this, you see here. Now, whenever anybody is asking you, or whenever you are studying about isotherm is nothing but the points connecting or line connecting points experiencing the same temperature. One important point that you need to ask is which season, because the isotherm varies from season to season. In the summertime, isotherm will be different. In the winter, isotherm will be different. Therefore, whenever anybody is asking you about saying something or drawing or writing something about isotherm, the most important point that you will have to ask yourself is whether it is the summer isotherm or winter isotherm. The isotherm which is there in front of you, it is a January isotherm. You see here. Just now I have explained to you. You see here in this. In a winter time, since the land specific heat is much less as compared to the water, it will cool down at a faster rate. And remember, we are calculating this based on the assumption or based on the foundation that in general, the moment I go from equator towards the polar region, my temperature reduces because sun insolation is more or less near the equatorial region. Therefore, the moment I go away from equator to either of the polar regions, North Pole or South Pole, temperature reduces. So my isotherm will also accordingly will draw horizontal line. Now you see here, in the land area, since it is cooling at a much faster rate, in the same latitude if I go and see, the water temperature will be much higher. Why? Because water has more specific heat. Therefore, during winter season, it will cool down at a much slower rate in the same latitude. Clear? Therefore, in order to get this temperature, it has to go upper in the latitude. That's why this is a winter time isotherm. You see here, over the water, this is Atlantic Ocean. Over the water, my isotherm is going up like this. The moment I come to land, it is coming down like this. You see here, which means the change of temperature over the water is very gradual. Whether it is increasing in the summer, decreasing in the winter, it is happening very gradually because of more specific heat. But the change in the temperature over the land area is much faster. Clear? Now, another important term that you need to know is the thermal anomaly and the isonormals. What is thermal anomaly and what is isonormals? You see here, this particular variation in the isotherm, okay, this particular curviness, the curviness in the isotherm, Stevenson, what is VOA? Yes, Stevenson. See, any one of you, if you have any doubt, you can interrupt me at any time. Okay. Yes, Stevenson. What is VOA? I am not aware of that. FYI, I know that is for your information. What is VOA? Yes, Ishida, are you able to follow? If you have any doubt, you can kindly go ahead and ask me. You can interrupt me at any time. Yes? I'm waiting for the reply. It will be very nice if you can clarify that one. What is VOA? Anyways, we'll continue with the discussion. Okay. Yes. You see here, this curviness of the isotherm, like you see here, isotherm line, that is line joining places experiencing the same temperature, is different in the land, different in the water. Now, this is because of the differential distribution of land and water. Say for example, if the earth is completely homogeneous, if it is, say for example, if this land in the entire earth's surface, if it is occupied by land or if it is completely occupied by water, what will be the isotherm? In the homogeneous earth, isotherm will be a straight horizontal line like this, following the latitude like this. Okay, this will be the isotherm, you see. But as you know, in the earth's surface, it is not homogeneous. In some area you have water, in some area you have land. You see here, in this particular isotherm, if we compare the distribution of land, the land mass is more in the northern hemisphere as compared to the southern hemisphere. Therefore, in the northern hemisphere, the curviness of the isotherm is too much, you see here. But when you come to southern hemisphere, beyond this particular region or from around 40° north, you find a very isotherm, a straight line like this. Why? Because it is a homogeneous area. Even in this area, you can find almost a straight line, the isotherm. The reason is the land mass is very small, and in other part, it is covered by a homogeneous surface of water. Clear? Now, this difference or the curviness is because of the unequal distribution of land and water over the earth's surface. Clear? Now, what is thermal anomaly? A term known as thermal anomaly. Now, thermal anomaly, it is very important. Kindly pay attention. Thermal anomaly is, say for example, you consider a very homogeneous earth where the isotherm is a horizontal line which is parallel to the equator, just like a latitude. Now, but this is an idealized form, okay, when you consider the earth to be a homogeneous. But in real, because of different distribution of land and water, the isotherms are not straight line, but it is having curviness like this. Now, thermal anomaly is you consider any location on the Earth's surface. Say for example, I consider this location, any location on the Earth's surface. You go and try to see this particular latitude, compare with the idealized or homogeneous Earth, what should be its mean temperature. Now, but in real, the temperature that you will not hear will be different. The difference of the actual reading and the mean compared to this particular latitude is known as thermal anomaly. Clear? Now, what is this isonomals? Isonomals are line drawn on a world map joining places having the same thermal anomaly. Now, if you go to this graph and see, locate the places having the same thermal anomaly. Just now I have explained to you what is thermal anomaly. Now you go and find the places on the map, any locations that is experiencing the same thermal anomaly. Say for example, as per this particular mean temperature of this latitude, say it should be 25 degrees centigrade. But in real, if you go and see, the temperature is, say for example, 30 degrees centigrade for this particular location in this particular latitude, which means you have a thermal anomaly of 5 degrees centigrade plus. Now the line joining places having the same thermal anomaly, it is known as isonomals. Clear? Any doubt? The term is important. Thermal anomaly is important. Isonomals is important. Isonomals is line drawn on a world map joining places having the same thermal anomaly. This particular thermal anomaly can be of two forms, positive and negative. Positive means if the places is experiencing a temperature much higher, okay, much higher than what it should be in the homogeneous Earth. That is plus. If any location is experiencing less temperature, then it is assumed to be in the homogeneous Earth, it is known as negative thermal anomaly. I hope that is clear. Yes, Ishita and Jyoti, are you still there or? Yes, any doubt, Ishita? Jyoti? Okay. I'm not getting your response, so I'll just go ahead. So that is okay. So we have completed the characteristics of temperature on the Earth's surface. Okay, its insolation as well as the temperature distribution. We have studied isotherm, okay, isonomals, and also thermal anomaly. Okay, these are very, very important. Clear? Now let us go and see the basic characteristics of a pressure gradient. That is, we have studied temperature. Now let us go and see the pressure gradient. Okay, in order to understand the wind system, okay, the wind system on the Earth's surface, the interplay of temperature and pressure will lead to formation or generation of certain wind system. Okay, you see here, we all know air will flow. Okay, air will flow from high pressure area to low pressure area. How a low pressure area is developed? A low pressure is developed on the Earth's surface whenever there is a high insulation over any place on the Earth. What will happen? The air will be heated up. When the air is heated up, it becomes light. When the air becomes light, it will move up. When it moves up, it creates a vacuum here. And this vacuum is nothing, or the space is created. And this space or the vacuum is nothing but the development of a low pressure area. So from the surrounding areas, a wind will rush towards this particular low pressure cell. That is how a low pressure is created. And the other region which is having a pressure above this particular low pressure region, it is known as a high pressure area. In a very, very simple. Yes. Yes, actually there was some connection network issue here. I'm very sorry. You see here, the moment this particular air started to flow like this, it is not going to flow straight line like this. Why? It is because of the Coriolis force. Now you see here, there is one force known as Coriolis force. What is this particular Coriolis force? Let us see. You see here. Let me give you one example. Okay, first let me give you one example. Kindly pay attention. Say for example, there is two location. Okay, suppose if it is a rope. Okay, it is a rope and I will rotate this like this, in this way. Okay, this is a sender. Two location A and B. Now, this location A and B, the points A and B, you just keep this in mind. Now, if I rotate this rope, okay, like this, go complete circle and comes back to this particular location, B will also trace its path like this. A will trace its path like this. Now, both the points A and B will travel this particular path. Now the time taken is same. The time, because see, the moment B goes and reaches here, A will also go and will reach here at this place. So the time taken is similar, means it is exactly the same. But you see here, what is the distance that is covered? The B covered more distance as compared to A. Clear? Which means, can I say that the velocity of B while going around this point, the velocity of B will be much faster? Why? Because you see, time taken is the same, but the area which is traced, it is more for B. So in order to do so, velocity needs to be increased. Therefore, the velocity of B will be much greater than A. Clear? That is clear? Now, if that is clear, you kindly come to this particular diagram. Merry-go-round. You see here, say for example, this is the sender and this particular is rotating in this manner. You are sitting here exactly at the opposite and your friend is here. Now, if it is rotating in this direction, who will be rotating at a faster velocity? Your friend will be rotating at a faster velocity as compared to you. Why? Because at the same time you are finishing one round, but the area that is covered by your friend is more as compared to you, because you are covering this area only, your friend is covering this area. Now you see, say for example, your friend is here, you are here, your friend throws a ball to you. Now, your friend will be throwing, the direction will be straight to you like this. But where do you think the ball will fall? The ball will not reach you. Even if your friend is targeting you and throwing the ball to you straight, but the ball will reach ahead of you. In front of you, the ball will go and reach like this. It will travel like this. The reason is, you see here, since your friend is traveling at a faster velocity as compared to you, the ball which was carrying or holding by your friend is also traveling along with your friend, traveling with a higher velocity. So the ball will also is traveling with a higher velocity. Therefore, the ball will fall in front of you like this. Okay, say for example, it is you, your friend is here. If your friend is throwing the ball straight away to you, the ball will rather go ahead of you like this. And it is because of the rotation. Therefore, the earth has two motion. One is it rotates around its own axis. One, it revolves around the sun. Now you see here, because of the earth rotation, any moving object is deflected to the right in the northern hemisphere, deflected to the left in the southern hemisphere. This deflection of the moving object, it is not only the wind, it can be aeroplanes, it can be any moving objects. In the northern hemisphere, you see here, this is earth rotating around its own axis like this. You see here, this is equator. In equatorial region, it is the largest area. Okay, if you go towards the polar region, the area becomes less and less. It is zero right at the pole. Now you see here, it is rotating like this. If a object is moving from this equatorial region towards any of the polar region, what do you think? It is just like a ball throwing from this region to this. So will fall ahead of that particular path. Therefore, you see here, okay, therefore you see here, whenever from the equatorial region, if an object is moving in this direction in the northern hemisphere, it is always going to track towards the right. The Coriolis force does not affect any other parameter of the moving object. It is only affecting the direction. So it will be tracked towards the right. Exactly the opposite in the southern hemisphere. Whenever an object is moving, it will be tracked towards the left. That is known as Coriolis force. And this Coriolis force comes into being because of the rotation of the earth. If there is no rotation of the earth, no question of any Coriolis force. Say for example, you don't rotate this disc, then what will happen? A friend is throwing a ball to you, it will straight away come and reach you. Okay, clear? Therefore, the Coriolis force, because of the Coriolis force, you see here, whenever a wind will flow from high pressure region to low pressure region like this, instead of going straight, the intention is to go straight like this. But the moment it goes, a Coriolis force will track it to the right. It is in the northern hemisphere, mind you. Now, the Coriolis force will act continuously, and one of the characteristics is the Coriolis force acts at the 90 degree to the direction of the motion. Now, it acts continuously, so initially it was like this, it is tracked to the right, kindly follow the pointer. Now, again, this particular Coriolis force will act 90 degree. It will continue to change the direction, tracking the moving object to the right continuously. Okay. Carol. Okay. Now, what will happen? A time will come when this particular wind will be parallel to the low pressure and high pressure isobar. These are isobar. Isobar are nothing but the line connecting places having the same pressure. So at this point in time, this particular pressure gradient force, which is this, I have already explained to you what is pressure gradient force, and the Coriolis force, they will equals out each other. One is acting towards this, other is acting towards this. They will balance each up. They will balance out each other. From this particular moment, this particular wind is no further tracked towards the right like this. It maintains in this position. Why? Because it is equal and opposite direction. This pressure gradient force and Coriolis force, they are acting. This particular wind will start to blow in this particular parallel line with respect to the isobar like this. This particular wind is known as geostrophic wind. I hope that is clear. So the initial force difference through which a trigger is given for the wind to flow from one place to the other, here in this case from high pressure to low pressure, it is known as pressure gradient force. But the moment the wind started to flow, because of the rotation of the earth, Coriolis force will come into being. The Coriolis force, the nature is it will track the direction into the right in the northern hemisphere. It will continuously do so unless it reach a point when the pressure gradient force and the Coriolis force equals each other, acting in opposite direction, maintaining a flow which is parallel to the isobar. This particular wind is known as geostrophic wind. I hope that is clear. Yeah, any doubt? Carol, work tech. Today you are everybody is writing in a kind of a letter which I am not able to get. But anyways, is it clear? Yeah, is it clear? So that is known as pressure gradient force and geostrophic force, geostrophic wind. Okay, very important. And this is Coriolis force that we have discussed just now. Any doubt, any point? Now, we will end the session here today. We will continue with this tomorrow. Okay, different types of pressure cells that are developed on the Earth's surface depending on the latitude. In the equatorial region, what is that? In the polar region, how it is? And we will try to see what are the different wind system, planetary wind system, like the trade wind, the westerly, the polar easterly, so on and so forth. And not only that, but also the vertical circulations which is there. Clear? Anyway, thank you so much. We'll end the session here today. We will continue from